Okay, I want you to copy down and try this exercise. So, pause, copy, copy. Pause, copy. Try. Okay, here we go. The answers are N is 2, N is 3, B is T 1 to 1. Yep, yes. Yes. Is it on to? No. So if you have any questions about that, please ask me during class. Now, moving on. Theorem 11. Theorem 11. Simply stated, T is 1 to 1, where, well, T is let's not specify too much about T. We'll just say T is a transformation if and only if T of x equals 0 has only the trivial solution. Only. Trivial solution. Okay, let's see if I can remember how to prove this. Okay, so this is an if and only if. If and only if, meaning I have to prove that the first statement implies the second, and also the second statement implies the first. So I can do this in 2 steps. So I can start by just proving this direction for the arrow. So if t is 1 to 1, then t of x has only the solution. It's only the trivial solution. So what do I need to prove here? I need to, okay, first of all, assume that this statement is true. T is 1. And then with that assumption, I have to prove that t of x equals 0 vector has only the trivial solution. Okay, t of 0 is equal to 0. We proved this earlier. I forget if it was, I think it was 1.8. And let me see, I feel like I'm forgetting something here. Oh, theorem 11, I believe I need to say that let t be linear. I need to have a linear transformation. For theorem 11, add this little bit at the top. Okay, we proved earlier that t of the 0 vector is always the 0 vector if t is linear. And we'll say and t of x equals 0 has at most one solution. Since t is 1 to 1. Therefore, okay, I know that t of 0 is 0, and I know that this equation here only has one solution for x. Therefore, x equals 0 is the only solution to t of x is equal to 0 vector. Okay, in other words, well, this statement, t of x equals 0 has only the trivial solution. Okay, how about the other way around? Now I'm going to assume that t of x equals 0 has only the trivial solution. Okay, I want to start from that assumption and prove that t is 1 to 1. So how am I going to do that? Well, fancy tricks. What I'll do is I'll say, let's say that t of x is equal to b has two solutions. X is equal to x1 and x is equal to x2. I will prove that x1 equals x2. Okay, so I'm trying to prove that t is 1 to 1. So I'm trying to prove that this guy here always, for any b, has at most one solution. So what I'm going to do is I'm going to say, well, imagine there are two solutions. I'm going to show you that they have to be the same. So they are two solutions, right? So t of x1 is equal to t of x is equal to b, and t of x2 is also equal to b. So t of x1 is equal to t of x2 because they're both equal to b. And then my fancy trick is to bring everything over. So I'm bringing this t of x2 over to the left-hand side. Then I use the linearity of t to do that. And then I use my assumption, which, let me just pause here, let you write that down. And use my assumption that t applied to x equals 0 has only the trivial solution. Okay, so if I have t of x equals 0, that means that this guy here must be 0. Oh my gosh. x1 minus x2 is equal to 0. since t of x equals 0 vector has only the solution x is equal to 0. So therefore, x1 is equal to x2. Okay, what this argument does for me is it tells me that therefore t of x is equal to b always, that is for any b, has only no, has at most one solution. Okay, I proved that. I proved that if I have two solutions, then they turn out to be the same. They're not distinct. All right, therefore, t is 1 to 1. Okay, that proves the theorem.